So example 3, it says Marco hits a golf ball into the air from the 3rd level of a driving range that's 48 feet high. So if you just can imagine, we have some building here that's got a driving range on it, and somewhere on the 3rd floor, here Marco's here hitting golf balls up here, and he's 48 feet above the ground. The golf ball is going to follow a parabolic path until it eventually lands on the ground. Probably bounces after it hits the ground and rolls. Right? So anytime something's acted on by gravity, it's going to follow a parabolic path in some way, shape, or form. If you hit it up and then it goes down, it really looks like a parabola. If you hit it in a straight line, then it goes down. It's like it goes straight then down. It's still following a parabolic path. It's just not you're not getting the whole parabola thing. The only way it wouldn't be a parabola is if you do one of those. It might be a straight line in that scenario. But anyway, that's what's happening in this problem. Is he's hitting this golf ball, and it's going to go up in the air before it goes down and eventually hits the ground. All right. They tell us in the problem that the function h of t equals negative 16t squared plus 32t plus 48 gives the height h in feet of the golf ball t seconds after it is hit into the air. All right, so that sentence there is describing the motion of the golf ball. You can see it's a quadratic function. You can see the squared object is negative, which makes it an upside down parabolic function. So you can see that we're expecting this upside down parabola shape, right? They tell us within the words here that the height h in feet, so h of t represents the height of the ball in feet, t seconds after it is hit, so t represents the time after it's hit, where it's at. So if time equals 0, as he's making contact with the ball, 0 plus 48 is 48 feet high. The ball's right there. 1 second after he hits it, negative 16 plus 32 is 16 plus 48 is 64. It's 64 feet high. 2 seconds after he hits it, negative 16 times 2 is 4 is 64. Negative 64 plus 64 is 0 plus 48. It's back to 48 feet high, and so on. So you can just put numbers in and figure out some stuff like that. But the question they're asking us is this. When will the ball hit the ground? Larson, what does the word when mean?
Like when it's going to happen? I don't know. Oh, t.
Yeah, when is t? When's the time, right? So if they're asking when, they're asking to find t. When will the ball hit the ground? So if they're asking me to find t, so t equals something, some number of seconds, right? Then that means I should know what the height is, because those are the two variables in the problem. You should know one if you want to find the other. Okay? So if I'm going to have the ball hit the ground, what do we know about the height?
48.
Well, 48 is where the ball starts off. Where's the ground? This is the ground, right? How many feet high is the ground?
0.
And this is 48 feet high, so the ground is 0 feet high, right? If something hits the ground, height is 0. So so hitting the ground is just the thing that they tell us that allows us to see what the height is. They might say, when will the ball be 20 feet high, or 20 feet above the ground? Well, then you'll let h equal 20, and then solve for t. So if they're saying, when will this happen, you just simply have to represent what height is. But again, in this case, they didn't say height is 0. They said hits the ground. That implies height is 0. So with that in mind, I'm going to take this function here. I'm going to change h of t into the number 0, because that's what the height is, and I'm going to try and find out what t equals. So it's going to look like this. 0 equals negative 16t squared plus 32t plus 48. Now, there is a legal way to get rid of the 16s in this problem.
May I have your attention, please? Teachers, please dismiss the cross-country team at this time. Once again, please dismiss the cross-country team at this time.
Good luck, Colton. And when you're done running today, get a paper bag and cover that book, please.
Yeah.
Thank you.
Run to the store.
So, in an equation, you're legally allowed to multiply and or divide by any number you feel like, anytime you feel like it, all the way around. So this divides by 16, this divides by 16, this divides by 16. I could legally divide everything by 16. But for the sake of a factoring technique, I'd like to show you something here. I'm going to factor the 16 out instead. The other thing I'm going to point out in this specific problem is I always want my quadratic term, the one with the x or the t or whatever letter squared, that quadratic term, I want that to be a positive term. Currently you can see it's negative. It's much better if it's positive. It's easier to work with. So the fact that I can see that 16 is a common factor means I'm going to take 16 out. In order to make that t squared become a positive term, I'm going to factor out a negative 16. So taking the 16 out just divides everything by 16. Taking the negative out changes all the signs. So if I take negative 16t squared, extract a negative 16 off of that, it's division, I'm going to get a positive t squared. If I take a positive 32t and divide out a negative 16, I'm going to get a negative 2t. If I take a positive 48, take out a negative 16, I'm going to get a negative 3. So again, that's just a common factor scenario. Take out the greatest common factor and then reduce the function down to something simpler. Now, ideally, when I'm dealing with a quadratic function, having 1t squared is my best friend. That makes it the easiest problem it can possibly be, right? When it's something other than 1t squared, I got to do the whole factor by grouping nonsense, right? And the harder type of problem. But there's no way around it for right now. So if we can get it down to just t squared, though, it's real simple. I need two numbers to multiply to make negative 3. That also add to make negative 2. See, negative 3 times 1 makes negative 3 when you multiply. Negative 3 plus 1 makes positive 2 when you add. So, negative 3 and 1 are the magic numbers here. So I'm going to factor this. It's still going to be 0 equals. I got a negative 16 common factor. I'm going to have a t minus 3. And I'm going to have a t plus 1. Once we get it to factored form, then I use the zero product property, which if you recall from yesterday, the zero product property states that if a product of things equals 0, then one of the factors has to equal 0. So in this specific case, my factors are negative 16, t minus 3, and t plus 1. Anytime you factor the things that are the parts of the multiplication problem, each of those represents a factor of the quadratic expression. And again, if I'm using the zero product property, I'm simply going to state each one of these things individually equals 0. So either negative 16 equals 0, or t minus 3 equals 0, or t plus 1 equals 0. And that's just employing the zero product property. That's how you do it. Product equals 0. Each piece of the product equals 0 individually. Now back in Algebra 1, when you took Algebra 1 a little bit more than a year ago, you learned how to solve quadratic equations like this. You used the zero product property, then you had an entire year of geometry to forget how to do that because we maybe saw that happen twice in geometry the whole year. Right? So now we're back in algebra again. Now we're doing this property again. I want to remind you of a few things you learned back in Algebra 1 that you may have forgotten. In math, there are open sentences and closed sentences. A closed sentence, a closed expression, is going to be something that's either true or false. It gives you no basic information. It's just a statement of fact or a statement of non-fact. Then you have open sentences, which means that there's some variable, some changing value in there that allows you to sometimes be true, sometimes be false, and your job is to find out when it's true. Okay, with that in mind, this guy here is a closed sentence. There's no variable in that expression, right? It says negative 16 equals 0. The letter t is not there. It's just a number equals a number. Is it true? No. If it's not true, it gives us no information. It's not helpful. Okay. A lot of times people use the zero product property. They pull that number out, and all of a sudden they think that's an answer. Right? Again, it's supposed to equal 0. It doesn't equal 0, so it gives us nothing. Right? T minus 3 equals 0. This has a variable in it, so this is an open sentence. This has an answer. We chop the negative 3 off, make it positive 3. T equals positive 3. And then t plus 1 also has a variable in it, so chop the 1, move it over, make it negative 1, so t is equal to negative 1. So the answers to the question they're asking us, when does the ball hit the ground, would be positive 3 seconds and negative 1 second after the guy hits the ball. Okay. Now, when you're dealing with a real world problem involving parabolic motion, negative times don't count. Negative is before the problem existed. The problem starts when time equals 0. So if I get a negative time on one of these problems, I'm probably going to throw it out most of the time. You guys ever watch a rocket launch?
No.
T minus 3
Yes,
seconds.
exactly. That's what they say. It's T minus 10 and counting, right? They're negative 10 seconds. 0 is launch time. Okay, so basically you got a bunch of scientists launching a rocket. They're conducting a scientific experiment when the rocket goes off. All right? Time starts at 0. When they say T minus 10, that means 10 seconds prior to launch. T equals 0 is launch time, and every second after that is after launch time. And a lot of this has to do with mathematical formulas and stuff like that. In order to not have a parabolic,
What if the rocket fails to launch?
well, man, that's not good. But in order not to have the parabolic motion, because gravity pulls everything back to Earth, they have to have enough force to have escape velocity, they have to escape Earth's gravity to get out into space. So the scientists have all this technology and stuff to know exactly how much force they need to push that rocket through the atmosphere to get out of the Earth's gravitational pull. But anyway, the point is, negative times don't count because it's before the ball was hit. After the ball was hit, 3 seconds after the ball was hit, that's when the ball hits the ground. So when will the ball hit the ground? 3 seconds after it's hit. Now again, that's the question they asked. Here's another question they might ask. It's a question they pretty much asked last chapter on a problem like this. How high does the ball go? What am I looking for in that scenario? If it says how high does the ball go?
Height.
The height of what? The parabola. And what's the highest point of the parabola called? The vertex. So if they say what's the highest the ball will go, they're looking for the vertex. Now they could ask one of two questions. When does the ball reach its highest point, or how high does it get? If it asks when, it's looking for the t value. If it's asking how high, it's asking for the h value. Well, we can see the t value of the vertex is just like the x value here, right? So t is acting like x does. So the t value of my vertex is going to be the opposite of b. That'll be negative 32 over 2 times a. That'll be 2 times negative 16. What's 2 times negative 16, Larson?
Huh?
What's 2 times negative 16?
That would be negative. I don't know. I don't want to say it and be wrong.
You quit drifting off to sleep. I'll quit calling on you to answer questions. Dominic, what's negative 16 times 2?
Negative 32.
I was gonna
And
say
negative
that,
32,
man.
why didn't you say it then?
I don't
Negative
know, I was
32 divided
scared I was
32 is
wrong.
positive 1. So
I don't want to be wrong.
you said nothing, so you were wrong anyway.
Well, yeah, but
Right.
so
So-
to be that way wrong.
Negative 32 over negative 32 is positive 1. So positive 1 seconds is when the vertex happens. And the height at 1 second is going to be negative 16 times 1 squared plus 32 times 1 plus 48. That comes out to negative 16 plus 32 plus 48, which according to my calculations is 64 feet. So again, there's another question you're capable of asking with your current skills. How high does it go? When does it get that high? When is the time? 1 second. How high does it go? 64 feet. All right, so again, anything that they ask you about parabolic motion represents those things right now that you know how to do. When does it hit the ground? When does it reach a certain height? When does it reach its highest point? What is its highest point? All that stuff should be within your skill level at this point on these problems.